mu1 equals mu2 versus HA, mu1 not equal to mu2, mu1 greater than mu2, mu1 less than mu2. And they will give you n1, n2, x bar, y bar, sigma 1, sigma 2. Let's call it sigma x, sigma y. Here it's a z-test because sigmas are given. So z is equal to x bar minus y bar minus mu x minus mu y from the null hypothesis. X and y and 1 and 2 I'm using interchangeably, right? You know what I mean? When I say mu x, I mean mu 1, right? Divided by radical sigma x squared over nx plus sigma y squared over ny. That's z naught. And then you go and you drop this into your z picture, and either you reject or you do not reject accordingly. That's the first thing we learned. The next thing we learned was independent samples. They give you nx, ny, x bar, y bar, sx, sy. Now, comparison of means. The first thing you have to do is do an f-test. Do an f-test for comparison of variance. F-test for comparing variances. So it goes h naught sigma 1 square equals sigma 2 square, ha sigma 1 square not equal to sigma 2 square. This test will always be two-sided. F looks like this. You only care about the right critical value. You don't care about the left critical value. And you take your alpha and you split. So alpha over 2 here and alpha over 2 here. It's a right skewed distribution with numerator, comma, denominator, degrees of freedom. You decide which side is the numerator by taking the side with the larger s value. So let's say this is larger, this one. Then this would be the numerator side, this would be the denominator side. The degrees of freedom here would be ny minus 1, and that's the numerator degrees of freedom, and the denominator degrees of freedom would be nx minus 1. So the test statistic f naught is equal to sy squared over sx squared, and you make sure that you take the numerator degrees of freedom and the denominator degrees of freedom in that order. So let's make up some numbers so we can see. Let's say that this n is 9 and this n is 8. Then this degrees of freedom would be 8 degrees of freedom, and this degrees of freedom would be 7. So I will do this test at f 8, 7 degrees of freedom. That means when I go to my F table, I'm going to look up 8 here and 7 here and pick up the number. Let's do it. And let's say that alpha is equal to 0.05. That means this would be 0.25 and 0.25. So go to the F for 0.25. Make sure you go to 0.25. And then 8 and 7. So 8 and 7 gives me 4.8993. 4.8993. That's the critical value. And then you go and you drop this number f naught into this picture. If it falls in here, you do a pooled variance t-test. And if it falls in here, you do an unpooled variance t-test. Follow me. So then unpooled variance. The test statistic T naught is equal to x bar minus y bar minus mu x minus mu y over SP rad 1 over nx plus 1 over ny, where SP squared is given by nx minus 1 sx squared plus ny minus 1 sy squared over nx plus ny minus 2. For unpooled, oh, and this is performed at nx plus ny minus 2 degrees. And for unpooled, T naught is equal to x bar minus y bar minus mu x minus mu y divided by square root of sx squared over nx plus sy squared over ny. And this test is done at new degrees of freedom, where nu is obtained from the calculator. They're both t-tests. Have an idea now? Okay.